Whenever you have a question asking you something about even and odd numbers, and does it have to be even, does it have to be odd, what about the product, and so on and so on, make your life easier and take the information they give you right here, right? Two integers with different parity, one's even, one's odd, and just pick two integers. You don't have to worry about whether you picked the right two integers or the wrong two integers. Like here, I'm just going to pick a equals 1, b equals 2. See, one's even, one's odd. And I don't have to worry about all the other possible ways I could do this, because anything that works for those integers that I just picked is also going to work for any other set of even odd integers. Okay. Yeah. Of course, there's exceptions to that, but let's just work through this and see what happens. So a minus b equals what? Well, a minus b equals, according to the numbers I picked, -1. That's odd. So that one must be odd. Now, right away, we run into the first exception. I don't believe this. So A, does it have to be odd? Well, no, it doesn't have to, because I could have picked A equals 2, B equals 1, right? So it can be even or odd, just depending on what I picked. This is an exception. Likewise with that one. But any combination of A and B, that's what I was really getting at. So if I said A squared plus B squared, let's think about what that is. That's going to be 1 squared plus 2 squared equals 1 plus 4 equals 5. So that's odd. And then A times B. Let's see what this is. That's 1 times 2, and that equals 2. So that's even. Okay. And you can play with this list if you want, over and over and over again. For any combination of odd and even numbers, you're going to get these same answers that I did on the left. The only time you run into a possible problem with what you choose is super simple cases like this, where they're not combining A and B in any way, they're just asking you about A and B.